Hello everyone, and welcome to our first Lunch and Learn for 2023, building easier, faster and cheaper modern mobile experiences. My name is Erin Nash and I'm the Head of Marketing Partnerships and Communities here at DiUS. Before we get started, I'd like to begin by acknowledging the traditional custodians of the lands that we are meeting here today. I pay my respects to elders past, present and emerging, and celebrate the diversity of Aboriginal peoples and their ongoing cultures and connections to the lands and waters of Australia. I also acknowledge their ongoing cultures and connections to the lands and waters of Australia. I also acknowledge and pay my respects to our Aboriginal and Torres Strait Islander people joining us today. Now, in case you haven't worked with DiUS before, we're an Australian technology consultancy that specialises in using emerging technology to design, develop and deliver cutting-edge solutions. This includes our in-house expertise across digital data and devices, which of course includes our modern mobile capability, which is where today's talk fits in. Now, without further ado, I'll hand over to Mike Hughes to kick off today's talk.
Great, thanks, Erin. So today we'll just do a quick introduction and talk about a new Q&A approach that we're going to try for this presentation. We'll talk about modern mobile and what that means to us and to you. We'll talk about customer mobile needs in a fair bit of detail, because this is really important on how we come up with mobile solutions for clients. We'll also then talk and hear from Brett a little bit more about where Flutter is sort of going, given that Flutter is one of our sort of slightly preferred frameworks for mobile solutions at the moment. And at the end, we'll sort of wrap up, and we will announce merch or swag winners at the end as well. So stay tuned for that. So today we're going to hear from a few people. It won't just be listening to me the whole time. Many of you will be happy to hear. So we'll hear from myself first, and then we'll also talk to Trevor. So Trev is my co-special interest group lead on mobile. He's also a lead software engineer at DiUS. He's been around a long time, and many of the mobile projects that you'll hear about today, Trevor's worked on many of them. So very experienced mobile software engineer. We'll also hear from Zoran briefly, and he'll tell us a little bit more about Power Sensor, which is a startup that involves an app and a hardware device that talks Bluetooth and Wi-Fi, and some of the challenges around transitioning from traditional native apps to something a little bit more modern. And finally, we'll hear from Brett as well about where Flutter's kind of going in the future, given that Flutter is our slightly preferred sort of multi-platform framework at the moment. So questions and merch. So we're not going to do traditional Q&A at the end, because we find that really doesn't sort of work for anyone really well. So I'd encourage you to go to slido.com, use this code or scan the barcode with your phone camera now, and actually log questions in Slido. I'll stick on this slide for just a little bit, just to give you enough time to scan the QR code. That way we can actually get questions and probably answer some of them offline a little bit later, and make sure we give you proper answers. The other thing is merch. So we're giving away 5 Flutter merch packs today for anyone who's registered and attended this presentation, and we'll announce those winners at the end. And I'm sure I've got some helpers that are beavering away as we speak, seeing who's attending and who's not, so that we can choose those winners. So another slight improvement that we're trying for this presentation today is Trev and I are going to make ourselves available after the event from March 1st to the 7th to discuss your mobile issues and questions in probably a lot more length and time than we have here today. So all you're going to need to sort of make the most of this is to join the DiUS community Slack, which is a public Slack, and we'll send you that invite in an email after the event. But what we'd like to encourage you to do is spend almost a week with us after the event discussing your mobile problems, issues, questions. And if we can't answer your question specifically, Trevor and I will go to the wider DiUS team to answer those questions for you and give you some sort of advice. I'd call it free consulting, but I'd probably get shot if I called it that. But make the most of the opportunity, because it's the first time we're trying this. So please join the DiUS community and have a chat with us sort of after this event for up to a week. So first, and I'm not going to harp on this too much, mobile. Why is mobile important? Who's on mobile? Well, the short answer is most people, but I think this is a bit of a given for this audience. I think we all accept that mobile is super popular these days. Who's not on mobile is really the question that needs to be answered these days, because pretty much most adults and a large percentage of the population in Australia, New Zealand, and Southeast Asia are on mobile. So this is perhaps not the burning question that it was, say, a decade ago. So interesting enough, being at almost 80% of the population using a smartphone, and only second behind the US, is still pretty impressive. So we should highlight here too, when we say modern mobile, we're perhaps bending that definition, or what you may immediately think of mobile, a little bit, and that term. So the modern bit, part of that is looking at other connected devices. So we don't do lots and lots of work using other connected devices. Most of our mobile work is iOS and Android. But what we are seeing is things like, tablets, wearables, connected smart TVs, car systems, assistants. All these other connected devices are becoming, or they're starting to emerge as hard requirements for clients. So we're seeing this come up more and more. So part of the whole definition of modern mobile extends to thinking about some of these other connected devices, because they will play an increasingly large role in a business's overall mobile solution going forward. The other reason we include them under the banner of modern mobile too is that a lot of the back-end technologies and languages, SDKs, etc., that are used for things like iPads, Google TVs, and assistants use mobile technology anyway. So it's a convenient way to bring those devices under the banner of mobile tech. So just a quick definition. So the term modern mobile is the name for our approach to building mobile solutions for clients. The modern bit is used to distinguish our approach from what I call traditional native development for, say, iOS and Android, for example. So whilst we're open to all technical approaches to build mobile experiences, we often find multi-platform frameworks like React Native and Flutter often better achieve client mobile solutions, and the requirement for easier, faster, cheaper, which we hear from clients over and over and over and over again. So that's our definition of modern mobile, just to give everything a bit of context in today's presentation. So just quickly, let's break that down just a tiny bit more in general terms. So how do we and a client achieve easier, faster, cheaper? I won't hit all these points, but just to call out a few. Easier is effectively all about less work effort for the team building the digital solution. So things like single code base versus multi-code base can be really, really important in reducing the total workload. I'm sure we've got code generation, automation, a whole bunch of tools and techniques to make it easier and to reduce the developer or designer effort. And choosing the right technology is sort of key to that. But at the end of the day, easier is all about less work effort to build the digital product. That then leads into faster. So the process to build, if we take a lean and agile approach, that helps us with the process of building digital products. But of course, faster is also very relative. So faster to one business is not necessarily faster for another business. So we need to keep that in mind, that it's faster is a relative term. The other thing we find too is that single cross-functional teams tend to work faster, quote unquote, than multiple tech teams broken into, say, an iOS team and an Android team. We also know that a product-led approach is often key to getting to mobile solutions a lot faster. But at the end of the day, faster is all about less work effort results in faster. Cheaper as an extension of that. So if we're spending less work effort and we do it faster, we should get to significantly lower cost. So I know a lot of you in the audience, if you're not a developer, if you're representing a company or a business, you're always about, well, how can we get a quality result, a better result, even cheaper? So that is also a relative term. So it's relative to how much funding you have available, your budget limits, and similar. But at the end of the day, these are the things we hear from clients. Getting digital solutions to a very high quality and standard built easier, faster, and cheaper. This is what we hear on a daily basis from our clients. And the one thing around cheaper too that I neglected to mention is maintenance cost. So maintenance cost is a very real cost of total ownership. So we can't forget about that as well. So this is how we get to easier, faster, cheaper, but we'll break it down a little bit more. So mobile solutions, we see a lot of clients get hung up on the technical solution, on what they need for their mobile solution. So just a little bit of color here on how do we choose, or how do we help clients choose their technical solution. Number one, it always depends. So whilst I said at the beginning that Flutter is a bit of a slightly preferred choice as a front-end framework at the moment for us to build sort of Android and iOS apps, that's true. It's still not the one size fits all. So it always depends, depending on the client requirements. And we can't forget too that for you guys that work for specific businesses and companies, these are big decisions. Like going with one particular technical solution or mobile framework is a big decision that you're going to have to live with for a long time and has large impact. So you need to choose really carefully. The other thing that colors these choices too is we often find clients fall into one of two buckets. Has the mobile tech choices already been made? So what we find is for very large companies, think the banks, a lot of the banks made their mobile platform choices, technical choices, a long time ago. And so they're still running with those choices. So we see a lot of large companies already having made their key technological choices for their mobile solutions. Whereas we see small and medium enterprises and startups are more likely to have new products and projects that they're just getting going on. And so they need to think about their tech choice. That's not to say also that large, big companies also have new greenfield projects that they start from time to time. And so they may go through the process of coming up and choosing a tech solution for their new mobile app. And Trev will talk about one of these examples a little bit later. But what we see, the most common combinations are still when clients come to us and say, look, they want a mobile app, they're talking iOS and Android. The days of clients coming to us and saying, look, we just want an iOS app or we just want an Android app, those days are long gone. It's very few apps I'd suggest these days only want to be on iOS or only want to be on Android. The other big chunk of our work is obviously also web apps. And by web apps, I mean not necessarily a company website or web page that serves up content and information, but is an actual functional service on the web for a particular business. The other thing too, just to reiterate, connected devices are increasingly required as part of mobile solutions for businesses. So they're becoming an increasing trend, if you like, that just goes into the mix of the mobile solution for the business. The other thing that we're seeing too is competition versus customer experience. So whilst a lot of mobile solutions need to get direct access to things like GPS and NFC and wallets and other mobile device features, some solutions for clients can either be web or mobile. And what we've seen in the past is clients have often just done web because it's cheaper and easier. So they may have done a responsive web app for their particular use and they've run with that. But what we are starting to see is more and more customers come to us where all their competitors have the same sort of technical solution. They're all got mobile responsive web apps. That's great. So if a client wants to differentiate themselves in the market, often what they need to do is be moving into mobile away from just your vanilla responsive web app. So that's an important factor as well that's starting to emerge now. And as we know, the other thing that frames mobile solution tech choices is hard limits like cost and schedule and people and the team that a company has. And one really strong theme here is a company will often go with a technical solution framed by the existing development team. So what's the team they've got on the ground? What skills does that team have? Ergo, that leads to the technical solution. And one last thing that, again, is becoming a bit of a trend is supporting technologies. So when we're talking about a mobile solution, today we'll primarily focus on the front-end frameworks like your React Native, Flutter, or native apps. But the supporting technologies are becoming a bigger and bigger part of the mobile solution. So embedded tech, IoT, devices, machine learning and AI, big buzzword at the moment. What's going on at the back end and how the cloud services work that back end the app. What's going on with the technical solution around DevOps and CI/CD. These are all really, really big questions and that are really, really, really big parts of the total mobile solution. So these are just some of the things that sort of frame solutions for clients and businesses. So broadly speaking, when we're talking modern mobile, we're kind of talking about a couple of different types of technologies. Very, very broadly speaking, we're talking about web apps and native apps and multi-platform apps. Now, in the past, really the choices are you had the choice of doing a web app or you had the choice of doing a native app. Multi-platform apps, and especially some of the older frameworks, weren't particularly mature or ready to actually sort of fill a practical role in a cost-effective way. So if you can take one thing away from this presentation today, it's to think about multi-platform apps now being a very real, mature, practical, cost-effective, time-effective solution to getting to a native mobile app experience. And so that's really a huge takeaway from today. It's a new option that we find a lot of our clients aren't necessarily across, and they're still thinking native apps or web apps, and that's kind of it. So one other thing to think about when we're looking at a client's requirements about their mobile solution, we're also thinking around some of these things that frame the decision. So, does the client have an existing code base, i.e. sunk cost in an existing mobile app of some kind? Do they have an existing team? Again, sunk cost on skilling and training a team that's on the ground at the client. What does that look like? Are there cost pressures? Are there time pressures? Are there special issues? So if we take a theoretical company, let's call it Acme, what does that mean for Acme? And this is just an example of some of the thought processes we go through when we're sort of trying to come up with a recommended choice for technology solutions for clients in the mobile space. So, for example, Acme might sort of be on, at these points on these spectrums of various things. So if their existing cost base is close to none, there's almost little or no existing team, there's not an inordinate amount of cost or time pressure, and there's no huge special issues, then that's a scenario when we definitely lean towards a technical solution of React Native, Flutter, or the web to do things easier and faster and cheaper. On the flip side, if these sort of markers are way down this end, then we tend towards recommending a traditional native solution for clients. So that's just an example of how we sort of think about the big factors that go into that choice. So talking about those technology choices, let's just sort of elaborate those a little bit more and compare them a little bit. So web apps were arguably the original multi-platform framework, although we probably can't call it that. So we have had responsive web apps running on mobile for a very, very long time. And arguably web has been probably the most successful multi-platform solution potentially over the long term. So it's still very much a viable option, and it still represents a large chunk of the work we do for clients. There's lots of technology choices in play when it comes to web. Won't go into too many of those, but key things to think about are that the web is also changing and improving as we go. So WebAssembly is coming along soon, although that's sort of still cooking and isn't particularly practical solution at the moment, but it gives us, for the web, near native performance through bringing in languages like C and C++, Rust, etc. So the web is evolving still. The other thing about the web too is, generally speaking, you can say it's a single code base, so that helps digital products use one team to build a single code base and to build a digital solution. And The other thing to note, though, that web apps have traditionally been a little bit limited on platforms. So, for example, getting direct access to the native platforms to get to things like, GPS and Bluetooth and etc. has been a little bit limited on web apps, and that's helped sort of constrain their use depending on what's needed by the business. Just a quick update, though, it is changing again. So iOS 16.4 that's coming up, Safari will allow web apps to be put on your home screen and push notifications. So that's an example of how web apps are still evolving very much as mobile solutions these days. And on that note, I might throw to Trev to talk about native.
Thanks, Mike. Yeah, so continuing on from where Mike just dropped off there with the web, the next level, of course, is native apps themselves. So the obvious thing about native apps is you have to write for each individual platform. So I can't write an iOS app and then suddenly magically compile it and have it run on Android. So that necessarily means two different code bases, which brings a whole lot of problems in its up on their own. Things like your business logic has to live in two different sources, so you don't have one single source of truth on your data, on your business logic. And that brings maintenance headaches. And if there's bugs in one, then maybe in the other. If you fix it in one, it might not be fixed in the other. There's all sorts of issues there. Also, another issue here is feature drift. So one development team might go faster and be able to push out a feature before the other one's ready. So you've got a disparity between your two platforms. It's obviously the highest dev cost because you have to have either two teams or one team of unicorns, which are very rare indeed. And even then, if you have that magical team, they can only work on one code base at a time. So it's twice the team in effect. One of the big advantages, obviously, of native is that you have access to everything available on the phone. So all the sensors, all the new stuff. A big one at the moment is VR or XR, VR and AR, which is not that easy to access through React Native or Flutter at the moment. And you have 3D renderer, which can be important in some situations. Okay, next slide, please. So React Native. Sorry, I just need to, there we go. So this was one of the really early cross-platform. I think I wrote an app in React Native way back in 2016, I think, but it was very limited. But I really liked the idea of being able to have single code base. So all those problems I just talked about didn't appear. That you could have a single team working on both apps. You could get an app out to both platforms at the same time, and it had feature parity. And it was. I really liked the idea of where React Native was going. It has near native performance because React Native uses the C bridge to be able to communicate directly to the underlying platform. Although that's getting a lot better now with the latest release. That improved speed in that is quite amazing. And you have an immense ecosystem of libraries you can draw from, which is what React is really known for as well. With that comes the downside that some of those libraries are absolutely fantastic and some are less than good. But that's you have to do due diligence on your libraries, obviously. What else was there about this? One of the reasons that React Native is quite popular is that web dev teams feel that they can pick it up easier because it's written in the same language, either TypeScript or React Native. JavaScript, that's it. They are similar, but there's enough differences to catch early learners off, but you pick it up pretty quick. One of the downsides I found is CSS styling. Sad face. One of the things I really liked about it was hot reloading. Happy face. So yeah. Next slide, please. One of the apps we worked on was Tradicore. They had early on decided to break from their traditional development, which was the two separate platforms, and do React Native to speed them to market and to be able to have both platforms for a reasonable price. The team were web devs who took it up, and they focused mainly on the iOS app to begin with. I was brought in a bit later to help implement the Android side of things, and we got that done in 6 weeks from scratch. So it wasn't even building at the time I got there, and we got the first Android release out within 6 weeks. The initial estimate was that this would improve their user base by about 33%. It ended up being well over 40+ percent increase. So that, I think, was a success. And that's me. I think you're off next. Back to Mike.
Thanks, Trev. If I can push the button. Okay, Flutter. So just to add a bit of color to what Trev mentioned about React Native, we think a majority of our work in the mobile space in terms of writing front-end mobile apps is either Flutter or React Native at the moment. This is because we hear this catch cry from clients: easier, faster, cheaper. We get that all the time. So that's why a lot of the work we've done in the last few years has tended to focus on either React Native or Flutter. That's just a historical fact. Some of the reasons you'd sort of lean into Flutter, and as I mentioned at the beginning, Flutter is probably our slightly preferred multi-platform framework at the moment. And we'll hear a lot more about where it's going from Brett in a little while. But at the end of the day, Flutter, the same sorts of things as React Native. It's multi-platform, iOS and Android native apps. You can actually do desktop, Windows, Mac OS, and Linux as well, and native as well. That's great, although we haven't seen a lot of that coming from clients in the market, but it's great to know that Flutter is nice and mature in building both desktop and web apps as well. Single code base like React Native, the benefits of a single code base are substantial in and of themselves. Having worked with many clients in many teams, single code base lends towards single team, and that in and of itself is a huge benefit to a company or a business building out an app. It has a whole bunch of intangible benefits, and we'll probably do future talks at a next level of detail down, and single code base and single team will be a common thread through that. You'll hear a bit more about that in the future. Near native / native performance obviously compiles down to native machine code for apps. I don't want to get too hung up here on the absolute millisecond performance of one versus the other. It always depends. It always depends on how you write the code. But the main point from our point of view is that we can get to native performance, or the difference is so marginal devs can't even tell, let alone users. So native performance, if you want to generalize, which is fantastic. So we love building highly performant sort of native solutions. And like React Native, it has a package ecosystem. The Flutter package ecosystem has grown really, really quickly, really, really strongly. But again, it's that same thing as React Native. There are some good packages, there's some bad packages, but certainly a very strong package ecosystem. And just to clarify, the package ecosystem includes plugin packages that include native code for iOS and Android. So native plugins, fantastically performant in Flutter apps. So we can get access to pretty much everything that the native teams can get access to on the device. couple of quick examples around Flutter apps that we'll work on. I won't read through all this text. So these, you'll get the pack after the event, so you can read through this in a bit more detail. And there are links to the app stores and some blog posts that we've done or the particular company has done. So Total Wellbeing Diet has been working on a Flutter app that we've been helping them with on iOS and Android. And interesting enough, this is an interesting case in that this Flutter app needs to talk to wearable devices. It also has two flavors of the app. So there's iOS and Android branded as the Total Wellbeing Diet app. And in the States, there's the Mayo Clinic Diet app, which is a separately branded app, and it's actually separate app on iOS and Android. So that's a very interesting use case. And that's a Flutter app that has been very successful. And you may have seen some advertising in TV and press lately about the Total Wellbeing Diet. Another good example app is the Brighter Side app, which was done for the Black Dog Institute that we helped them with. Again, there's a case study here that you can link to when you get the pack afterwards to read more about this. But I guess that the big thing here was that the iOS and the Android apps were built using Flutter in 13 weeks to get the apps on the stores. So that was a really good result to get up and out to market really quickly. So Brighter Side was a good example of that easier, faster, cheaper nature of using Flutter in this case. One app that we'll talk just a little bit more about, we're going to bring in Zoran to chat about this, is a power sensor app. So Power Sensor is a startup that's also closely aligned with DiUS. And Zoran's been managing the team for, can I say, several years, Zoran, I think. And Zoran, if you can perhaps just sort of quickly intro Power Sensor and just tell us about the journey of Power Sensor, because you did start as a native app, didn't you?
That's correct, yeah. I mean, excuse me. Thanks, Mike. Essentially, Power Sensor is a physical device. So it's an energy monitoring device that we've launched. It's into market. It started, I think it's been at least 5 years that we kicked off the development. And as you say, we did start off with a native approach, and we had very specific requirements in the product. So the app needed to be able to talk to a physical device. So we really wanted the app experience to be controlled in terms of how the device communicated with the app over Bluetooth and Wi-Fi. So that was a very specific requirement that we had. So it kind of moved us into the native app side, because Flutter wasn't as big a thing at the time. And of course, web wasn't really an option, although it would have been tempting because we just didn't have that low-level control over the Wi-Fi and the sort of what was happening over Wi-Fi and Bluetooth. Mm. Now, back then, the app was really very simple. It was an install app only. And we were actually looking to decide whether we build the capability of the app. And I think that's about the time when Trevor was looking into Flutter, and he recommended Flutter to us. Now, some of the things that we were sort of facing early on at the time, just reflecting on the comments that you guys have made, if I can sort of paint a picture, Power Sensor is really a startup. So we had, very limited access to developers. I think Trevor gave the example, if you're going down the native path, you need the iOS team and I guess the Android team. Well, that truly would have been a luxury for us. Invariably, we didn't have, two streams running concurrently. So we very rarely had the two versions of the app aligned. So that, although in the early days wasn't as big an issue, I think today would be a significant issue, given we've launched into the market and the app has been significantly enhanced since those early days. So from a developer point of view, from the single code base point of view, yeah, it's been great. The other one, I'm not sure whether it was mentioned, just the UX consistency between the apps. So our UXers and our developers love it from that point of view, in that we can go out with essentially a highly consistent user experience for our users as well, all in with that single code base.
Is it fair to say, Zoran, also that you guys were pretty brave at that time, sort of deciding to change over to Flutter when it was fairly early? I think it was around Flutter version 1 when it became stable.
Yeah.
Can you just quickly mention, because we didn't start with Flutter developers because we didn't have many at the time, but
we had one.
We had one. Trev.
We had Trev.
Yeah, we had Trev. So Trev was championing Flutter within DiUS. And like I said, we were making a decision to greatly uplift the app. And we did want to move away, given all the issues that we had with keeping the two apps in sync and things like that. So Trevor bootstrapped us, and essentially he got us going. And for the most part, though, since then, the app has been built by embedded developers. So these are guys that's very hard to get them out of C and C++. So they actually really learnt Flutter mostly on their own. Of course, they tapped into Trevor and a few of the other guys that were when they were available, but yeah, they self-taught themselves. They were embedded developers that sort of, had been coding in C and C++, and they have really taken us through that major uplift, and they've loved it. So just in terms of the language itself, Dart, the compiler in terms of the way it picks up compilation errors, the linter, which enforces a lot of the structure in the code and the consistency of the code, has meant that we could get other people coming in and upskilling them and moving along as well. So it's really been a huge benefit for us.
Yeah, it's interesting because I also worked with Trevor on the High Pages Tradie Core app. Comparing and contrasting, it's quite similar to the Tradie Core team on the High Pages side, where they had web developers that learnt React Native and got up to speed with that multi-platform framework to produce 2 native apps and get them on the store. I find that it's a very similar journey, I think, that PowerSense has gone on. We had probably better keep moving. So on this note, I'll just skip to probably the last slide before we hear from Brett. So probably this is another call out that we developed a Flutter app for. So DiUS didn't have a Flutter, an actual app, iOS and Android app. So we did take up an offer from the Google team to use the new Flutter News ToolKit to get us going. And the long story short here is in just a few weeks part-time, Trev, I, and a couple of others basically pulled together the Medius app for DiUS, which we're continuing to enhance and is on the App Store and Google Play. So we were able to do that in record time. I think it was under 5 weeks to get the initial version out, Trev, if I'm not mistaken.
Yeah. But there was more work after that. But yes, the initial MVP was out in about 5 weeks. Yeah.
So that's good to know too. So just to keep on time, at that note, we might change over to Brett. Brett, are you happy and ready to talk to us about perhaps where Flutter's going, just because it is our slightly preferred multi-platform framework at the moment?
Yep, I'm here. Just queuing the technology. Do you want to stop sharing?
Stop sharing.
Cool. So in theory, I should have a deck. Hello, I'm Brett Morgan. I'm a Flutter Developer Relations Engineer working for Google, and I'd like to talk to you about an event we held recently called Flutter Forward. So let's dive in. What was Flutter Forward? Flutter Forward was a great little event we ran in Africa, introducing what we're doing with Flutter over the coming year. Just to place things a little bit, how is Flutter doing in the market? Here's a snapshot of where we are. We've got a whole bunch of Flutter developers, about 5 million or so, lots of Flutter apps in the Play Store and App Store. And most importantly, from everyone's perspective, is that we have a lot of people helping by contributing to the Flutter project on GitHub, as you can see here with the status of the Octoverse report from GitHub 2022. Just before Flutter Forward, we actually announced the latest version of Flutter 3.7, and the latest version of Dart 2.19. And it was actually kind of interesting to announce these before the event. It caught a whole bunch of people by surprise, but here's a quick overview of what's new in Flutter 3.7, which is our current stable release. First off, we have enhanced Material 3 support. This is absolutely brilliant for those of you looking to adapt to the new Material themes that are a part of the latest version of Android, and also being able to use Material on larger screens like desktop or the web. And the important thing here is that we've had members from the Material team, being Roddy and Liam, who basically talk you through what's required to take a design from, say, Figma and implement it using Material as the base layer, and then customizing on top of that to get your look and feel. So that's a great video to dive into to understand the full workflow of implementing on top of Material. Sorry about that. So that leads to an interesting question. Okay, when you're adapting to, say, the new version of material with its changed attributes and all that sort of thing, what's the easiest way to do that? Usually what people do is they'll do a Flutter pub upgrade, and suddenly they'll get a whole bunch of yellow squigglies all through their source code. And they have to go through and individually upgrade things using our fixes. Well, strangely enough, the infrastructure behind the IDEs giving you the ability to do these in place one-by-one upgrades is actually available for you to do in batch. And that's our wonderful Dart fix -- apply. This will then, depending on your configuration of your linters, anything that's throwing a linter warning or a linter error that has a fix that can be applied will be applied with this, this command. If you'd like to know more about that, here's a wonderful video by my colleague Khan, where she dives into what Dart Analyze and Dart Fix can do for you and making your application easier to maintain and grow as Flutter changes. What else is new in Flutter 3.7? Adaptive layout. This one's close to my heart. I like the ability of Flutter to be able to build big screen experiences, be they inside of a web browser or on the desktop, like iOS, oh sorry, not iOS, Mac OS, Linux or Windows. So adaptive layout is all about having the screen change, having layouts change, and start talking about different styles of input. And for a deep dive into this, we have a talk by Justin and Craig, where they'll go through and teach you all that you need to know about adapting to the different world that you get on desktop and web with a bigger screen, with things like laying things out differently and input methods. And of course, it wouldn't be a talk by me if I didn't call out one of my code labs. And here's a code lab where I walk you through building an animated responsive app layout using Material 3. So Material 3 is new. This code lab will walk you through getting started with Material 3. What else is new? Menu bars and cascading menus. This is important for desktop. This is all part of making Flutter equally capable on all 6 platforms that we support. This is useful. Now the fun part, getting into, and I'll be talking more about this later in the talk, Impeller. Impeller is a new capability that we're basically showing off as part of Flutter 3.7. It's available behind a flag in Flutter 3.7. But as part of building this out, we worked with Grant Skinner over at G-Skinner to really show off all the capabilities that you can get to with Flutter using animations. And as part of that, Grant created a new package, Flutter Animate, where he created effectively a new way of configuring animations that are much easier to approach than the traditional Flutter approach. And he's created a video about it. I'll have a set of links at the end of the talk that you can point your phone at to get to all these videos. What else is new? We heard from a bunch of y'all that releasing Flutter applications on iOS is more difficult than it should be. So we've written some additional tooling into our release tool that will turn around and check for common error conditions. So yeah, dive into that. It's a whole bunch easier. And of course, what would a Flutter release be without an improvement in our dev tools? I really hope you all are using dev tools to find where you're dropping frames and where you're using too much memory. It's a really good set of tools. Okay, that was a bit of a rush. So there's a Medium post by Kevin Chisholm where he goes into detail all the things that are new in Flutter 3.7. Strongly recommend you give it a read through. Okay, as a developer relations engineer with Google, that's usually where I would stop. But at this event, as foretold by the name, we actually are talking forward and talking about what's coming in the upcoming releases that we'll have approximately every quarter throughout the rest of the year. So this is all about what's coming in the future. So let's dive into that. The first thing is Dart 3, or more specifically, Dart 3 Alpha. So what's in Dart 3 Alpha? First off, records and patterns. Records and patterns are an interesting set of things that we're adding to the language. Calling back to my days supporting Google Maps, you frequently have the requirement to have the ability to return multiple things from a function. In this case, we have a function that gets the lat long for where something is, and we want to return that. Now, we've got a couple of ways of doing this in code. Having a list of doubles is probably the least good way of doing this, because we suddenly don't know which is light, which is long. There's nothing in the type system, there's nothing in the naming that actually gives a hint to the person using this API what the heck's going on here. So one way around this is to create a class that's just for the return value. It's got latitude and longitude. Suddenly we have names for these things, but this is actually quite heavyweight. It's a lot of code to have to write just to effectively name the parts of the return value. Wouldn't it be better just to turn around and say that this function is returning two doubles, or a double and a string, or those sorts of things? And so that's what we get. What we have here is a record. It's returning multiple things at once. Yes, $1, $2 are actually correct and viable names for parts of methods and values, but it's probably not the nicest way to do it. There's got to be a better way to actually tidy this up in code. And so what we're going to do is the other half of this, which is patterns, where we can turn around and apply a pattern, or if you're coming from TypeScript, destructure the return value and say, okay, we've got a lat, a long coming from get location, and then on, we can just use them as local variables. We can always, of course, ignore a incoming variable or update something we already own. So all of this is all perfectly acceptable. But to stop in a second and go, patterns and records sounds great, but isn't Dart an object-oriented language? And well, yes, it is. So how does patterns and records apply when you've actually got objects? So let's take a completely kind of strange case and have, let's say we have an abstract shape, and we've got a square and a circle that are both shapes, and we want the ability to add the ability to calculate the area of this shape. Strangely, you should actually just use polymorphism for this specific use case, but let's say for some reason you didn't own the shape class, but you still wanted to add this functionality to it. Okay, so we're going to create this function, calculate area, and then we can match the shape. Now that's wonderful. We can now say, in a case where we have a square or a circle, we can do something. We can do more than that. In this case, what we're doing is not only are we matching on the type, we're actually destructuring the object and going, I'll have the length or the radius. And now this is not directly appearing inside the object. We're not breaking the veil of the object. We're just using the accessors, because length and radius both have accessor methods because they are externally visible. So this way we can just turn around and grab the attributes of the object and then use them in a calculation like this to calculate the area. To go, there should have been a video. There's a video. Okay, to go further into it, here's a video by Bob Nostrom. He's a member of our Dart programming language design team, and he talks on about, okay, how would you use records and patterns in implementing a programming language? Yes, he has a hobby of designing programming languages while being a programming language designer. It's all very meta. It's kind of what you do when you're a Googler, right? Okay, what else have we got here? Sound null safety. This is probably the more impactful change that will come through Dart 3. We're actually, well, let's motivate this a bit more. If you look back in time, well, almost coming up on a decade now, I suddenly feel old. Back in the good old days, we had the ability to basically ignore the types in Flutter, or in Dart, sorry. This is well before Flutter came out. This was great because it matched the underlying environment we were targeting at that point in time, which was JavaScript. But of course, that meant that you could have these mistakes that were only visible at runtime, which has problems from the point of view of developer velocity. So with Dart 2, in 2018, we introduced type safety, and suddenly applying a string to something that's declared as an integer was a compile time error, which cleans a whole bunch of things up, and suddenly a whole bunch of errors disappeared from your life as an app developer. What about Dart 2.12? Dart 2.12, which is a couple of years old now, we split the types. Up until that point in time, all your base types like integer or string also included the magical variable value null. Now, this has upsides and downsides. Downside being you basically have to do null checks absolutely everywhere, and if you don't, you'll get that whole, null pointer exception. So here's the problem. You are using the get int, and you assume you always have an int, and at some point in time, it all blows up on you. With Dart3, we're changing that. We're enforcing sound null safety absolutely everywhere. So what does this play as? If we look at the output of Dart1 compilation, so this is the code we're running. It's just an attribute accessor. This is the Intel x86, well actually Intel x64 assembly generated for this accessor. If you read through this and you know your x86 assembly, you realize it's actually doing making sure that there's an object there, so it's doing a null check, and then it's figuring out what the type of the object is to make sure it has an age accessor, and then accessing that object, that attribute, and pulling that information out. It's doing a fair amount of work here, basically because the runtime cannot rely on the compiler to actually feed it an animal here. It could be anything. So it's doing a lot of work at runtime. With Dart2, suddenly the runtime could rely on the compiler to actually enforce type safety. It now knows that A is an animal because it's specified that way, which means it has a lot less work to do, but we still have to do the null check. So, we still got a fair number of assembly instructions for this one action. Dart3, this simplifies right down. We now have we know the object's there, we know it's not null, so we can just access the age attribute of the animal and return it, which means this is absolutely wonderful, especially from the point of inlining. Okay, what other neat things is the Dart crew working on? RISC-V. Dart is a wonderful programming language. It has support for a bunch of platforms. We're growing the pie a bit. So currently, as you can see, we support ARM and Intel on both 64-bit and 32-bit, as well as, of course, JavaScript. But the world is growing a bit, and what we're going to do is we're going to be adding RISC-V and WebAssembly. So diving into RISC-V, this was a great part of the talk where we were actually demoing on stage Dart running on a RISC-V dev term. This is a wonderful toy that if you enjoy building electronics at home, you can look it up. You can order one. It comes as a kit. The fun story behind this is that the product manager who was responsible for talking about this on stage was actually building this terminal the night before the presentation in his hotel room. I wouldn't have left it that late, but traveling internationally sometimes doesn't leave a whole lot of time. To go deeper into this, we've got a wonderful talk by Max, who's one of our Flutter GDEs in Melbourne, where he talks about getting Dart running on RISC-V and using it to do music. Lots of fun stories here. It's wonderful to see Dart going to a lot more places, and RISC-V is probably going to be something to watch in coming years, especially in embedded spaces. The other one that we mentioned is WebAssembly. Unfortunately, I don't have a lot more to say here about WebAssembly at this point in time, but Flutter is coming to WebAssembly. Watch this space. It's going to be huge, I think. What else is coming? Elements embedding. This is something we've heard from a lot of people who've currently got a website and they want to add some functionality to it. They basically would love to use Flutter, but have currently been stopped by the fact that Flutter, as it's currently run, requires you to replace the entire page with a Flutter application. This is wonderful for some situations, but not so great if you already have a website and you just want to replace a div somewhere with some content. What element embedding is going to give with the next stable version of Flutter is the ability to turn around and just drop some Flutter content in a div somewhere on the page and have the rest of the page unchanged. So this is expanding the reach of Flutter greatly. Another one is pixel shaders. Pixel shaders are a fun technology. They will enable graphics-oriented programmers to do all sorts of really cool-looking effects. Here's some now. The wonderful thing about pixel shaders is that they are about running code on the GPU of your device, so you can turn around and create these visual effects without tying up the CPU or your rendering pipeline. Just have the GPU do the work for you. Great for adding some splash and some finish to a graphical application. Of course, we have a video about this. This one's by Brian and Leia, where they go into both a wonderful new feature called variable fonts, where you can take a font and you suddenly have more control over the font. You do change various attributes of the font, which is of course defined by the font data, whether it's sort of like, say, the weight or the height or descender, whatever. There's a whole bunch of things that different fonts are now exposing. And on top of that, they use shaders to turn around and take the font that was changing and apply various visual effects. What else have we got? FFI-Gen and JNI-Gen. Something we've heard from a lot of developers is they need the ability to reach more into the operating system or to various native packages. So FFI-Gen and JNI-Gen are our ways of being able to work with, say, the native Java application programming interfaces that are available on Android, or the Objective-C and Swift APIs available on iOS. So they're both interesting new capabilities. Of course, there was a sample about that. I'll just skip past this. Health Connect and all that sort of stuff. If you want to go a bit deeper into this, Max, again, helped me write a code lab about using FFI in Flutter. And in this, we go through how to set up Clang and have it generate headers for a C library, and then use it on iOS, Android, Windows, Linux, and Mac OS. Okay, what else have we got here? Impeller. Impeller is going to be huge. This is something that I encourage you all to look into and spend some time with. It's definitely an upcoming change. Apologies. So here you can see one application that's written with a stupidly large number of lines using our traditional rendering pipeline. It's absolutely maxing out the display. It's averaging about 10 frames per second. On Impeller, it's suddenly doing 60 frames per second and not struggling at all. So why am I bringing this up for you? See if I can actually break out of this. What we're aiming to do with Impeller is to eliminate a problem we've had on iOS for a little while. The first use of iOS with our traditional pipeline was always a little bit slow and janky while we were compiling the shaders required for that application. So what we've done is we've rewritten the low-level rendering pipeline to break down shaders into a simpler, easier to compile thing, so that we don't have this first load jank problem that we were traditionally having. We encourage you, especially if you're shipping Flutter on iOS, to try out Impeller, maybe through a beta or something like that, and make sure that you aren't seeing any problems. If you do see a problem, I encourage you to raise an issue and ping me and tell me the issue, and I'll get it in front of our Impeller engineering team. If we don't see any major issues come up by the time the next Flutter stable is out, then Impeller will become the default renderer for iOS. We're continuing to work on Android, and that will be coming as soon as it's ready. So how do you do it? The easiest way to get started is Flutter run --enable -impeller. The documentation contains other ways so that you can build it into your CI pipeline and all that sort of thing. For a deep dive, Chinmay has a wonderful half hour where he talks through a whole bunch of the underlying infrastructure required. And yeah, it's definitely a wonderful whirlwind tour of how Impeller works. And of course, the one more thing, well, Impeller is giving us access to the underlying graphics card. So one of the Impeller engineers turned around and made one of my jokes obsolete by exposing the underlying 3D graphics capabilities and allowing us to load object files from, say, 3D graphics programs into the Flutter widget tree and turn around and instantiate 3D objects in the Flutter tree, and wrote a game using it. This is obviously not massively ready for prime time yet. This is still initial development as we work things out. It's only available if you're actually running Impeller as your rendering pipeline, and we're figuring out the APIs above this. But this is very much an indicator of where we're going, and it will become increasingly possible to write 3D games in Flutter using the native GPU capabilities of the platforms. A couple of more quick previews. We have 2D scrolling. I know we've had horizontal scrolling and vertical scrolling, and you can glue the two together, but there are use cases, especially in desktop and the web, where you want to have the ability to scroll diagonally and have that make sense. So Kate is implementing that at the moment, and she gives a wonderful little intro talk talking through what's involved in that. Another thing we've heard is that people on desktop don't want to be stuck to one window. They want the ability to have multiple windows available and have the state line up between those windows. So Michael Gertebauer is working on this. He gives a talk that gives basically a snapshot of where he's at, but it's still very much work in progress. And this is a quick summary of everything we've talked about. Here's the new directions for Flutter and Dart. Here's the new things we're working on. Obviously, Impeller, Gen, FI Gen, RISC-V, so on and so forth. These are all the things we're aiming to ship over the coming year. And as mentioned at the top, here's the collection of videos I've been referencing through the talk. I suggest you pull out your phone, point it at that QR code, and go have a look at the videos that we dropped as part of Flutter Forward, including the full Flutter Forward presentation itself. And with that, I thank you for your time.
Thanks, Brett. That was a very impressive pace of going through that presentation. So thank you for that. Just a quick note: we will include a link in the email after the event to Brett's given this presentation. In a few other forums, we'll include a link to one of those to sort of perhaps slow it down a bit. Okay, I'll just jump back. If you can stop sharing, please, Brett, that'd be great. So after this event, we'll send through the link as discussed at the beginning, just to join the DiUS community Slack, so that you guys can join and perhaps chat to me, Trev, and the rest of DiUS about all things mobile. We'll also provide some links to some other mobile case studies as well. So some of the case studies we went through really quickly. So we'll send you links to those as well. The social links, and of course, we'll send you a copy of the DiUS slide pack, not necessarily Brett's. One other thing, we're a little bit limited on what we can talk about publicly. So there's some client work that we've done that's sort of commercial in confidence, and so we can't sort of publicly talk about that. But if you'd like to have a chat and like to know more, just email info@dius.com.au, and we can arrange sort of talking to you about other work we've done. And here are the merch pack winners. Clap, although you didn't necessarily have to do anything to win. Okay, we'll reach out to you all after the event to email, and we'll email you afterwards and just to arrange pack deliveries, etc. And on that note, yeah, reach out to me and Trev to discuss things either via the community Slack, which is this S tag, or otherwise email us.
Thanks, everyone.
And on that note, we'll close it out. And thanks for attending, everyone. We've just finished on time.